last week, when you added the vinegar to baking soda, you could have kept adding the vinegar, all right? Because the vinegar was the limiting reagent. It ran out before the baking soda, all right? So normally, up until now, we've always assumed that all the reactants are completely used up. Used up during a reaction. That's not always the case. Okay. Usually what happens is one of them will run out before the other one. Okay. So the other reactant we say is in excess. Oh, I need a C in there. There we go. So so you have one in excess, all right? The one that runs out is called the limiting reactant or limiting reagent, all right? This is the one that is used up in the kiln. It runs out first. So it limits how much of the products can be made. You just cross that out. The excess reactant means it doesn't run out. Okay. We say that there's leftover. Part of that is leftover from in the reaction. All right, so how do you determine the limiting reagent? I do it different than Mr. Booth does. Okay, so we're not going to follow these rules. Right? I can show you Mr. Booth's method tomorrow. I think it's more work, so I like my method better. Okay. Don't cross that out. We can come back. I can show you his stuff tomorrow. Let me erase all this. Now, these are going to be fairly long problems because there's a lot of information that we have to figure out. Okay, here we go. So here's our reaction. 2 moles of aluminum react with 3 moles of copper oxide to produce 3 moles of copper and 1 mole of aluminum oxide. Okay. We've put into the container 54 grams of aluminum and 124 grams of copper oxide. So on the face of it, people that don't know chemistry would say we have more of this, so this won't run out. But we know that's wrong. Why is that wrong? Well, it might be true, but why can we not use just grams? What do you always have to convert to? It's always got to be moles, right? Because the weight of it, the mass of it, is dependent on the molar mass, right, of what atoms are in there and whatnot. So we always have to convert to moles. So your first step is figure out how many moles you have of each reactant. All right, so step 1, moles of reactants. So you literally just go, okay, I got 54 grams of aluminum. One mole of aluminum is 27 grams, not 127. Which means I have 2 moles of aluminum. And then you got to do the same thing for the copper oxide. (124 grams of copper oxide. Molar mass of copper oxide is 79.5. Which means I have We're not done yet, though. That gives you the moles of each that we've added into the reaction. But if you look at the reaction, the ratio between these is for every 2 moles of aluminum, I use 3 moles of copper oxide. Okay? If it was 1 to 1, if it's 1 mole of this reacts with 1 mole of this, you can just look at these numbers and take the lower number. But if it's not 1 to 1, you have to do something first. You have to divide by the coefficient that is in front of the number. And this will give you the ratio. Okay, so step 2. Divide by coefficient in balanced reaction. So what's the coefficient in front of the aluminum? 2. So we just divide the moles by 2. This gives me 1. And then you divide the copper oxide by 3, which gives me 0.52. The lower number is your limiting reagent. Okay. Number 3, lower number equals limiting reagent, i.e., it's the thing that runs out first. So the copper oxide is the reagent. That means you will run out of copper oxide before you run out of aluminum. Okay, so the copper oxide will determine how much product you get. Okay, so now the rest of the question is, so that's just figuring out the limiting reagent. Now we have to figure out how much aluminum oxide we're going to produce. So now it's just a stoich problem, because the first step is to figure out which one's going to run out. So if I want to figure out how much aluminum oxide is produced, I go, okay, I take my limiting reagent. We've already converted it to moles, so that's the number you want to use. So we go, okay. I have 1.56 moles of copper oxide. We're right there at moles, so we can just jump onto the moles bridge, which is using the equation. And we know that 3 moles of copper oxide produces 1 mole of aluminum oxide. Does that make sense so far? So now I have moles of aluminum oxide, because those units cancel, but they want to know the mass. So that means I have to have the molar mass of aluminum oxide. So there's 102.0 grams in 1 mole. So that's just the molar mass. And if you punch those numbers into your calculator, you're going to get 53.0 grams of Al2O3. Does that make sense? People is blindly writing. All right. The limiting reagent will determine how much product is formed, right? Because it runs out. That's why you have to do this initial step of figuring out which one is going to run out first. Okay. We're not done though, because they want to know which reactant is in excess and by how much, i.e., how much aluminum is left over at the end. Okay? So we go. Do it in green. How much Al left over? All right, so how many moles of copper oxide were there? 1.56, this number right here. So that means we have 1.56 moles of copper oxide. What's the mole ratio in the equation between copper oxide and aluminum? It's 2 to 3. So that means for every 3 moles of copper oxide I have, or react, 2 moles of aluminum are reacted. Okay, so that's going to give me the number of moles of aluminum that is used up. Okay? They want to know how much is left over, so I can convert that to grams. What's the molar mass of aluminum? 27. So if I go 1 mole of aluminum is 27.0 grams of aluminum, I will get, what do I get? 28.1. 28.1 grams of aluminum. What? What does this number represent? This is the amount of aluminum used up, right? Because it's the amount that reacted with the 1.56 moles of copper oxide, right? So this is the amount of aluminum used. Okay? So if that's the amount used, how much is left over? Just subtract it from the original. What did we start with? How many grams? 54 grams. So you go therefore 54.0 grams minus the amount used gives me 25.9. Okay, does that make sense? It's kind of an involved process, all right? But you have to, first step, figure out which one is limiting. So you figure out the number of moles, you divide by the coefficient in the reaction. The smaller of those two numbers is the limiting reagent. It will run out first. Once you know that, you can determine how much product you have. And then you can also figure out how much of the other reactant is left over by using the same moles of the limiting reagent, the moles bridge, and if they want it in grams, you just use the molar mass. That gives you the amount used. This is the key part. People forget this. They think this is the answer. This is not the answer. This is how much you use, and you subtract that from the initial amount to get how much is left over. All right? We will pick this up tomorrow there. I'll show you a demo